When we think of NASA, our minds instinctively turn upward toward the vast, star-dusted canvas of space. But the quest to find life beyond Earth requires a profound understanding of life right here. For this reason, NASA isn't just looking to the skies, it's also diving into the deepest, most enigmatic parts of our own planet. Our world's oceans are a proving ground, a natural laboratory where the absolute limits of biology are tested every second. By exploring these alien environments on Earth, we learn how to search for life in the alien oceans of other worlds. The agency's focus has turned to the Mariana Trench, a scar on our planet's crust deeper than Mount Everest is tall. Located in the western Pacific, this is the most extreme oceanic zone on Earth. As we descend into its abyss, we enter the Hadal Zone, a realm named after the underworld itself. Here, sunlight has never reached. The temperature hovers just above freezing. It is a world of absolute darkness and profound cold, a place long thought to be utterly devoid of life. But the greatest challenge is the pressure. At nearly 0 meters down in the Challenger Deep, the water column exerts a force of over 0 times the standard atmospheric pressure at sea level. This is equivalent to the weight of 50 jumbo jets, or a stack of elephants, pressing down on a single square inch. It's a force that can pulverize metal and was once believed to make life a physical impossibility. And yet, against all odds, life doesn't just survive here, it thrives. In this sunless world, life is not powered by photosynthesis, but by chemosynthesis. Organisms cluster around hydrothermal vents, harnessing chemical energy from the Earth's interior. These extremophiles, or lovers of extremes, have evolved incredible adaptations. The Mariana snailfish, for example, has a flexible skull and bones that don't crush under the immense weight. Its cells are filled with molecules called piezolites, which stabilize proteins and prevent them from being warped by the pressure. These discoveries have fundamentally rewritten our understanding of biology. To study this hidden biosphere, NASA and its partners deploy technological marvels, remotely operated vehicles, or ROVs, built from titanium alloys and specialized syntactic foam to withstand the abyss. By sending these robotic subs and underwater labs nearly 11 kilometers below the surface, scientists can see, sample, and study this environment in real time. These missions are our eyes and hands in the deep, equipped with high-definition cameras, powerful lights, and delicate manipulators to collect geological and biological specimens. The knowledge gained here has profound implications for space exploration. One of the most tantalizing targets in our solar system is Europa, a moon of Jupiter believed to harbor a vast, salty ocean beneath its frozen shell. This hidden ocean, dark and under immense pressure, could host hydrothermal vents similar to those in the Mariana Trench. The technology we developed to explore Earth's deep sea is directly informing the design of future probes, like the Europa Clipper, that will one day search for life in that distant ocean. In the crushing darkness of the Mariana Trench, scientists hope to uncover creatures and systems that thrive in conditions once thought impossible. Each discovery, each sample, is a piece of a larger puzzle. By understanding the tenacious grip of life in the most hostile corner of our own world, we learn how to look for it in the far-flung corners of our solar system, turning Earth's deepest mystery into a roadmap to the stars. While our own planet's oceans hold mysteries, the quest for knowledge propels us even further to the outer solar system. Here, in the colossal gravitational grip of Jupiter, orbits one of the most compelling destinations in our search for life beyond Earth, the icy moon, Europa. For decades, Europa has captivated scientists. It's a prime candidate for an ocean world, a place where a vast body of liquid water is hidden beneath a protective outer shell. This is tantalizing because on Earth, wherever we find water, we find life. The scientific consensus is that for life as we know it to exist, 3 key ingredients are necessary: liquid water, essential chemical elements, and a source of energy. Europa might just have all 3. The evidence for this hidden ocean is compelling. Data from NASA's Galileo mission in the 1990s revealed a disruption in Jupiter's magnetic field around Europa, best explained by a global, saltwater ocean. Furthermore, The moon's chaotic surface of cracks and shifting ice rafts suggests it's being reshaped by liquid water below. More recently, observations have hinted at enormous plumes of water vapor erupting from the surface, offering a potential way to directly sample the ocean's contents. To investigate these clues, NASA is preparing the Europa Clipper mission. This isn't a simple orbiter. Europa lies deep within Jupiter's fierce radiation belts, a hazardous environment. So, instead of a constant orbit, the Clipper will execute a series of long, looping orbits around Jupiter, making dozens of brief, close-range flybys of Europa. This strategy allows it to gather immense data while minimizing exposure to damaging radiation. Clipper is outfitted with a sophisticated suite of scientific instruments. Its ice-penetrating radar will be our first look beneath the frozen shell, mapping the ice's thickness and searching for the ocean. A thermal imager will scan for temperature anomalies, pinpointing hotspots where warm ocean water may be close to the surface. A magnetometer will take precise measurements of the magnetic field, aiming to confirm the ocean's existence, depth, and salinity. Other instruments, like spectrometers, will analyze the surface, searching for the chemical building blocks of life. If the spacecraft flies through a water plume, a dust analyzer could even taste the ocean directly, analyzing its chemistry. While Europa Clipper is not designed to find life itself, its primary objective is just as profound: to determine if Europa has the potential for life. It will assess the three key requirements: water, chemistry, and energy, to create the first detailed portrait of a potentially habitable world. The mission represents a monumental step in our cosmic search, bringing us closer than ever to answering the age-old question: are we alone? At first glance, they seem worlds apart: the crushing abyss of the Mariana Trench and the distant ice-encased moon Europa. One is a familiar yet inaccessible part of our planet. The other, a frozen frontier millions of miles away. Yet, for NASA scientists, these two extreme environments are linked by one of the most profound questions we can ask: just how tenacious is life? What are its absolute limits? We once believed life was confined to a narrow band on Earth's surface, dependent on sunlight. But the discovery of extremophiles shattered that paradigm. These organisms thrive in conditions once considered lethal, forcing us to reconsider what makes a world habitable. In our own oceans, under pressures that would crush a submarine, life flourishes in total darkness. Around hydrothermal vents, ecosystems are powered not by photosynthesis, but by chemosynthesis, harnessing chemical energy from the Earth's interior. This proved the sun isn't the only source of life-giving energy, rewriting the rules for where we might find life. And that brings us to Europa. Beneath its frozen crust, evidence suggests a vast global ocean of liquid salt water. Warmed by Jupiter's gravitational pull, this hidden sea could host hydrothermal vents similar to those on our ocean floor. This is the primary objective for NASA's Europa Clipper mission: to determine if this distant ocean has the ingredients for life. By studying Earth's deep-sea vents, we learn what biosignatures to look for on Europa. The challenges of exploring the Mariana Trench, designing vehicles to withstand immense pressure and operate autonomously, provide invaluable engineering lessons for future probes. Earth's deepest waters are our training ground for a cosmic search. Ultimately, this comparison is about expanding our definition of a habitable world. It's a quest to understand if life is a rare terrestrial miracle or a common cosmic phenomenon, waiting to be discovered in the dark, hidden waters of our solar system and beyond.